Good morning. In last classes, we have studied about concrete, its ingredients, properties, effect of water cement ratio. Today, we will study the strength of concrete and the factors affecting the strength of concrete. The strength of concrete usually increases with number of days. As concrete gets older, the strength will increase if the concrete is made properly. These are the some factors which affect the strength of concrete. Mainly water cement ratio, quality of the materials like cement, sand, aggregate, and the moisture content in the materials, and the methods and quality of the compaction, curing, and proportion of design mix. These are the some factors which affects the strength of concrete. As you know, yesterday we studied that the quantity of water, if we add less, we don't get more strength. Similarly, if the quantity of water added is more, we don't get the high strength. At particular point, we get the higher strength, that is called OMC, optimum moisture content. It is observed by the experiment that 0.01% of variation in water content will affect the strength of the concrete in large scale, that is 1 to 2 MPa, kilonewton per cubic meter. That is 0.01% of the water added more, we will get the 2 kilonewton per meter cube strength less. Therefore, the water should be added as per the designed data, which will be calculated with help of slump test, workability test, consistency test, concrete flow chart test. Next, the material quality, that is cement, sand, aggregate. If the cement used is fresh, we will get high strength. If the cement is stored for more than 3 months, 6 months or 1 year, then the strength will be decreases. It is observed that for 3-month storage of cement, 15 to 25% of the strength of the concrete will be decreases. For 6 months of storage cement, 35 to 45% of the strength will be decreases. If the storage period is 1 year, then 75% of strength will be decreases. Therefore, cement used for the concrete work should be fresh within the 3 months. For important works like bridges, dams, etc., we have to use fresh concrete within 1 month. Similarly, other components like sand, aggregate, they should be free from the organic material, inorganic material, debris, algae. More important is algae, because sand is obtained from the river or streams where possibility of algae are more. If the sand particles or aggregate particles are covered with algae, then the strength will be decreases because of the decrease in bonding property. Similarly, the structure, texture, and shape of the aggregates are also considered, which affects the strength of the concrete. Similarly, the moisture content in these sand aggregates also affects the strength of the cement. 1% of water presence in the aggregates or sand, it will be permissible. If the percentage of water content or moisture content in these materials is more than 5%, definitely it decreases the strength of the concrete. Next, compaction. There are different methods to do the compaction. Compaction means consolidation of concrete mass by avoiding the voids, air gaps, which increases the density of the concrete. Automatically strength of the concrete will be increases. If the compaction is more, definitely will get the strength in early days. Similarly, curing is very essential component of the factor which affects the strength of the concrete. When cement reacts with water, there will be liberation of heat. It is observed that 1 gram of cement will liberate 15 joules of heat while hydration of cement takes place. So the evaporation of heats is try to go outside the concrete mass, in which path it will passes, there will be the formation of the cracks and shrinkages. To avoid these cracks, shrinkages, effect of heat, it is necessary to maintain the concrete surface cool by providing water, by putting water. That is called curing. Curing is the process of maintaining the concrete surface wet and cool to avoid the effect of heat in concrete mass. Next, the proportion of the concrete and mixing procedure of the concrete and efficiency of the workmanship counts the strength of the concrete. The grade of concrete, mixing of concrete, design of concrete is all affect the strength of the concrete. Next, concept of design mix. It is the process of proportioning the various ingredients which produces the concrete of specific properties in both fresh and hard state at a minimum cost with maximum strength. Generally, we are using M15 grade, M20 grade concrete for all RCC works, that is beam, slab, columns, footings, etc. But for specific concrete works like bridges, dams, water retaining structures, these grades will not workable. We go for higher grade of concrete, M30, M40, like that. So these are the special types of the concrete which are designed in laboratory with number of experiments to get the maximum strength with minimum cost. Following are the some methods of design mix, that is ACI mixed design practice, that is American method, USSR mixed design practice, that is Russian method, British mixed design practice, that is England practice. Then in India we are using IS mixed design practice as per IS code 10262 and IS 456 and SP 23. These are the guidelines which provides the design steps of mixed design practices in India. So the basic objectives of design mix is the concrete should be economical as possible as with maximum strength, and it should give good appearance where it is used, which place it is used. Then it should be easily workable every common man should be able to work with concrete. No specific skilled laborers, supervisors are used for the concrete works. So this is workable for common man. Common man can also use the concrete works. It should be durable and it should attain the maximum strength with early age. Factors considered in mixed design of concrete are strength of concrete, workability of concrete, durability of concrete, water cement ratio, quality of the materials like cement, aggregate, sand, water and some admixtures if added, then the properties of material, size, shape, texture and water content, and if admixtures are used, the properties of admixtures also considered. Next is curing, importance of curing and some methods of the curing for different works. The process of keeping concrete surface wet and cool by applying water after placing the concrete for some period is called curing, which promotes setting and holding of the concrete by reducing the effect of heat. It reduces the cracks, shrinkages, evaporation of heat and increases the chemical action, hydration, setting time, holding time, strength, durability and impermeability of the concrete. Different methods of curings are spraying and pounding. Water is sprayed on the concrete surface and water is stored on the concrete surface. Next, membrane curing, covering with sand, earth, sawdust, straw, cotton mats, gunny bags, etc. Using waterproof papers, chemicals, curing admixtures, cooling agents. In some specific concrete, application of heat is also made with help of steam, infrared radiations, electric curing is also made. Next, admixtures. These are the extra component added to the concrete other than cement, sand, aggregate, water. For specific purpose, for specific material is used. They are called admixtures, which reduces the permeability, setting time, water content, bleeding, segregation, slump, liberation of heat, cracks, shrinkages, etc. And these admixtures increases the strength, durability, workability, pumpability of the concrete. For specific reason, specific properties, specific material is used. Types of the admixtures, generally they are classified as mineral admixtures and chemical admixtures. Mineral admixtures are generally available in the form of powder in nature like fly ash, silica flume, rice husk, blast furnace slag, surki, etc. Chemical admixtures are some compounds or chemicals generally in the form of liquids. They are retarders, accelerators, air entraining agents, water reducing agents, plasticizers, super plasticizers, etc. For specific reason, specific admixtures are used. So this is a comparison chart between chemical admixture and mineral admixture. Chemical admixture are water soluble. They are mostly in the form of liquid forms. Mineral admixtures are finely grounded solid forms, that is finely powdered forms. Chemical admixtures used in small quantities, mineral admixtures used in large quantities. Chemical admixtures used for alteration of setting time to increase the heat of hydration, hardness. Mineral admixtures are used increase in workability, durability and decrease in cracking and shrinkages. Chemical admixtures are pure chemical compounds in the form of liquids, and mineral admixtures are the most of the times they are byproducts or waste material from the industries. So example, sulfates, aluminates, gypsum, plasticizers are best example for chemical admixtures. For mineral admixtures, fly ash, rice husk, surki, silica fumes are the some of the examples of mineral admixture. So thus this completes unit 1, that is chapter 1, introduction to concrete. So in next class we will study the second chapter, second unit. Thank you.